Well, welcome to the afternoon sessions on Tuesday. My name is Corey Sanders. I am the head of product for Compute, and I am here to talk to you about Compute and Compute services on Azure. We've actually got a lot of fun in this session. We got a lot of great demos. We've got some great guest speakers who are going to be coming up as well. So hopefully we can all have a good time with this and really learn a lot or talk a lot about Compute on the Azure platform. So with that, let me just get rolling. So, right off the bat, who am I? Well, a few things. One, I already said who I am. My Twitter handle is up here as well. I also do a weekly show called Tuesdays with Corey, which many of you may find enjoyable, many of you may find terrible. So you're going to have to judge that for yourself as you go check that out. But more importantly, throughout my history and throughout my work on the platform and on Azure, really learned a lot. I'm certainly a hard worker and definitely carry my work with me everywhere I go and always have. But more importantly, I deeply understand business. And so the combination of these two aspects has really grown in my personality throughout the years. So these actually are pictures of me. They are ridiculous. So let's move forward. Okay. So why is this interesting? Why are we here? Why are you sitting to talk about Compute on Azure? Well, the biggest reason is the cloud is changing expectations. The cloud is dramatically changing what both our customers are asking for, what your customers are asking for, what your internal customers are asking for, and what the world is asking for of your apps, of your solutions. And these changing expectations are dramatically changing what you need to build and what you need to manage as part of your environments. And so some good examples of this change: every company is becoming a software company. No matter what you build, no matter what you do, a big part of your work is now becoming software. And this is to lead this transformation, this digital transformation that you heard all about yesterday. This movement to software is dramatically changing the landscape of pretty much every solution out there. So whether it be Netflix when it comes to movie rentals, whether it be Uber when it comes to taxi companies, or whether it be Skype as compared to telephone companies, these dramatic shifts, these changes, change the landscape of the businesses that were before. And we're seeing this across every single industry. And to give you some examples of actual Azure deployments and how they're changing things, both existing and new, BMW changing the entire experience around driving their cars. They're going through a massive shift where this experience is deeply integrated with the life and choices of the person who drives. And so you can integrate, interact, monitor all of these aspects deeply integrated with that BMW that's running. And all of that, of course, new experiences, new transformation enabling this next generation of driving. NBC, obviously originally a broadcast company that broadcasted television channels, now a major media company that does tons of video streaming. And this has been a really exciting transformation for them, moving into the internet streaming as they actually hosted some of the most exciting, the most widely viewed solutions on the web with the Olympics and with the Super Bowl a couple years ago. And then Alaska, obviously an airline company, but has changed the experience of the customers who fly Alaska. If you've ever flown Alaska, you get this nice little handheld device that's deeply integrated with intelligence in the back end to try and understand how people are using their platform and understand how they can improve their experience with their platform. So all of these are dramatic shifts. None of these would you say are software companies, but all of them are innovating with these types of solutions with cloud in the background. And what you're going to see throughout this presentation is how Compute, as a specific portion of this cloud environment, really gears and drives towards offering agility to these companies. These companies are able to deliver this because they can move quickly. They can move more quickly than they would if they were just running this on their own environment. And that's for a lot of reasons. Maybe uniqueness of hardware, which we'll talk about, or uniqueness of partner solutions or scale out. And so what you're going to see throughout is that this application transformation that these companies are going through is really driven by agility. And all of the services that we offer and capabilities and experiences that you're going to see are all surrounded with that focus on agility. And so I'm going to spend some time talking about Azure Compute. And I'm going to spend some time talking about all the different services that we've got. And there's quite a wide variety of services and solutions. And across all of these, the goal is to be able to get you that agility. The goal is to be able to deliver those solutions that you want as fast as you want. And you'll see that with some of the demos. So to start off, one of the really exciting parts, of course, about Azure and giving you that agility and that uniqueness from your existing environment is, of course, the worldwide coverage. And you've seen this now perhaps a dozen times, 34 hyperscale regions available throughout the world. Very exciting. One of the things I did want to show you that maybe you haven't seen yet is some actual aerial shots of one of these regions. So we saw this in, the Dublin region as part of Scott's keynote, but this is actually the region in Virginia. The reason why I like to show this is that it not only shows you the scale, but also the growth and the change even for us as this market is changing. So here you can see it's a little van here at the bottom. That's me. I'm driving to work. No, it's not me. But this is the size of a van to give you scale. This is the first part of our Virginia region. And so we added these additions very recently. And so these are sort of the next generation of deployments, the next generation of hardware that we've added. And so that's the addition below those original deployments. And then just to give you a sense of this growth, this is the remaining space that we are now building on. Okay, and so just to give you a sense of, this is one region. You saw another one during Scott's keynote, right? So this is to give you the sense of how much this is growing, how much people are doing, the excitement that we're seeing from this ability to deploy fast, and deploy unique solutions. It's dramatically changing. So on top of this, so these regions are massive, they're growing. We've got 34 announced. But one of the cool things that we've offered here in Azure is a different approach to some of our regional deployments within country. So obviously there's a lot of requirements in some countries around compliance expectations, data proximity rules, so on. What we've done in many of these regions is we've deployed multiple regions within a given country to offer a DR option without leaving the boundary of the country. So if you're from one of these countries or you deploy in one of these countries and compliance or data proximity is important, this enables that proximity, that control, without having to leave the boundary. So within 300 miles or greater separation between these different deployments in Australia, Japan, China, India, Germany, UK, Canada, and US, all of them have multiple regions with that distance offering a DR solution. And actually our competitors don't approach DR in this way. And so this is a very unique opportunity. And I'm sure you're all impressed that I knew all the flags by heart. That's nice. It took a lot of practice. I won't say which ones were the hardest. Okay, so let me start off just quickly with some of the core parts of our service and how they're offering agile capabilities. The core parts of our service: infrastructure, compute. And when you look at this, it breaks up into 4 big parts: virtual machines, VM scale sets, our batch service, and our container service. So let me just start with VMs. Fairly good place to start. So our VM service, it's sort of what you'd expect. We offer a wide variety of VM solutions: Windows, Linux. You can deploy Ubuntu, Red Hat, SUSE, CoreOS, all supported, all with images directly available in our gallery. Deep integration with DevOps, whether it be Puppet or whether it be Chef or Salt. You can deploy these solutions very, very easily and get launching really, really fast. Lots of sizes, and I'll show that here in the next slide, the focus on and growth of sizes that we've seen in the platform. And of course, hundreds and hundreds of opportunities to deploy very quickly and very easily in our marketplace. And so to give you a sense of the wide variety of solutions we offer, whether it be load balancers, whether it be security firewalls, WAFs, whether it be other solutions like that, this capability to quickly and easily deploy a fully managed solution directly onto virtual machines is, again, a very unique solution. And the wide variety, whether it be SAP, whether it be Oracle, just being able to get going quickly and be able to launch these solutions and have your app up and running almost instantaneous. This is a very, very powerful thing and enables multi-VM deployments and single VM deployments as well. So I mentioned about sizes. So we have, prior to April, we had 4 sizes available. And the goal of these sizes is, of course, to be able to match your workload as close as possible, right? So again, it comes back to agility, but also cost, and making sure that cost management is an important aspect for us as well as for you. And so picking sizes, being able to find the things that's going to match your workload the best or support your workload at all, that's really a big goal of ours, again, to offer this agile capability to you. And so The four sizes, the A, the D, the DV2, and the G. And so the ability to deploy across these sizes, A being the lowest price one or the highest value one. D being, of course, the SSD storage, the fastest CPU at that time. I'll talk about some of the newest ones we just released. And then G was intended to be the monster SKU. It had quite a bit of SSD support and definitely had a lot of memory. And so this was sort of where we were about 4 or 5 months ago. But the world changes so fast in infrastructure. And this, again, is another good example where we are changing as fast as we can with this world and enabling that change without you having to go build out hundreds or thousands of these machines. You can just come to us and use 10, 20, 30, try them out. And this is one of the great things about it. And some of the things that we've launched. The F-Series went out. And this is geared towards driving much tighter workloads, much lower amounts of memory, but yet still very fast CPU focus. And so you can imagine some HPC workloads, you can imagine gaming workloads really fit the bill where CPU is a big factor, but memory may not be. Two really exciting SKUs that we've recently announced, and in fact have a focus special guest coming up here in a minute to talk about the NC and the NV. And I split them out here for you guys to see the distinction between these two. The NC, built on K80s, they are focused on more compute-like workloads, deep learning solutions. In fact, we're using them a lot internally for things like Cortana, for Skype Translator. A lot of the analytics work that we do internally are starting to use these or are already using these. And we're seeing a lot of excitement around this, both internally and externally, in being able to do these broad compute, massive compute-intensive workloads, and their connectivity between them is with InfiniBand. So near microsecond-based connectivity offering multiple machine computation to happen all at once. And then we have the visualization one, the NV, which is built on M60s. And we've seen a lot of excitement around enterprise or workloads, workstations that have a deep modeling requirement. So whether you're, let's say, an automotive engineer, or whether you're doing work on top of a movie or work as part of a game, and you need that visualization in front of you, these workstations, these engineering workstations are going to be very, very powerful to be able to get that experience right on top. And so these two have been in preview for a couple weeks, and we're actually going to show quite a few here, some demos and some conversation on that in a bit. The other two that we've announced this week, the H-Series, this is now the fastest CPU in the cloud. And so this is fantastic. It offers high throughput, very high speed InfiniBand connectivity between them, offering a really great opportunity to do massive scale workloads. And again, you're still paying per minute for all of these sizes. So you use what you need and you walk away, and that's fantastic. Again, giving you that agility to do that. And then L, really geared towards MySQL, sort of database solutions, a lot of SSD, a little bit less memory than G, so it's a little bit less expensive, fits your workload a little bit better in some of those cases. And then the AV2, which is going to be a lower price offer of the A series. So really exciting, and the key thing here, the level of innovation that we've had, we've more than doubled our sizes in a 6-month period. And this is just going to continue to go. There's so much more out there. There's so many more opportunities for us to continue to add investment and exciting new solutions throughout. And so, like I promised, I do want to invite Ian Buck up, the VP of NVIDIA Accelerating Computing, to be able to talk to you a little bit about some of the great work that's happening with GPUs on Azure. So come on up, Ian.
Thanks, Corey. Hi, everyone. So Corey invited me to talk about AI and explain to you some of the things that are going around AI and elaborate on what you can do with the GPUs inside of Azure on AI. So just some background. AI is everywhere. It's actually more ubiquitous than you realize. Every time you talk to your phone or ask a question to a Cortana or any of your phones, you're actually processing that your voice, your wave file, the audio is actually being processed in a neural network. It's done with AI, and most likely it processed on a GPU already today. It's in how we shop and how we interact. Pinterest. You can click on a photo and ask Pinterest, hey, show me where this bag is on Pinterest, and it'll bring up and search on their website using AI to look at the picture and understand and match with other postings on their website. We even do what AI says. It'll tell you what's the next movie you need to watch. Netflix uses GPUs and AI to actually figure out from all the movies that you watched and friends and other people like you, what's the next movie you should go see. It's touching our lives too. The Skype example is wonderful. A grandmother in Italy can talk to her grandson in the US and completely eliminate the language barrier. That translation is all happening in real time because the AI network that's built for translation is doing this live. It's helping in medicine. The Children's Hospital in Los Angeles is actually going through a whole decade worth of medical records and history, everything down to heartbeats and heart rates and all the data to figure out what symptoms lead to what diseases in children, so they can actually identify those problem cases sooner and prescribe medicines quicker to potentially save lives. Mining 10 years worth of medical records that they've all digitized. And finally, of course, the Seeing AI project here by Microsoft is amazing, really, truly allowing the blind to see. This person here has a camera in his glasses. The camera communicates with his phone, which streams the images up to the cloud. The cloud then interprets what the camera is seeing and tells him through an earpiece what he's seeing. Allows him to sit down at a restaurant. He can now read a menu. He can now tell a joke, and the Seeing AI project will actually tell him if the person on the other side is smiling or frowning. It can interpret and understand, not only that, it can tell him how old they are. It can tell him how many people are there. It completely changes the way he interacts with the world. Truly amazing work. It's also changing industry. Video surveillance and monitoring. We work with one company that actually works with malls. And they hooked up all of their cameras, hundreds of cameras in the mall, up to the cloud and to process the videos with AI. So if you lost your child in the mall, you can go to the security office, show them a picture of your child, and it will actually search all 100 camera streams and tell you exactly where your child was last seen in real time. This project is a fun one called Connie. She's a project with Hilton. It's actually a robot concierge. You can ask Connie questions like, where's a fun park? I'm interested in sushi, and it'll talk back to you and actually have a conversation. The service industry is changing. The chatbot, this is one example, but chatbots is another. You can interact with chatbots and understand and communicate. You could buy things on the internet through Messenger by communicating with a bot that's all powered by AI. And finally, industries like even agriculture. This is one company that have a project called LettuceBot. That's a lettuce field. And what it actually has is a forward-facing camera. And that camera is looking at the ground in front of it and deciding, is this little piece of green in the ground a piece of lettuce or a weed? And if it's a weed, it squirts just the bare minimum amount of herbicide to kill that weed, all powered by AI in real time. So by doing this, they can actually reduce the amount of herbicide they use. They don't use choppers anymore. They've reduced it 95%. As you can see from that field, that's a lot. That's a huge savings and obviously a great health benefit. Anyway, the point is AI is everywhere. It's fueling many industries. It's touching our lives. And I'm sure you can think about how it could change for your companies and your institutions. The reason why GPUs are so great at this is AI is a massively data-rich problem. It's a compute-rich problem. And the traditional CPU solutions aren't really delivering the kind of performance with every generation that's necessary to deliver that kind of compute. One view of the performance per dollar over every generation has been declining and decreasing year after year after year. Yet the data, the amount of computation, the amount of need for computing is going up exponentially. 1 in 5 searches on the internet now is done actually with voice. 20% of Google or Baidu, which is the Google of China, for example. 270 million things are sold on Alibaba every day. That's way too many things for Alibaba to actually monitor themselves. They actually use AI to make sure that what's selling is this a real Gucci bag or a fake Gucci bag? Is this drugs? Is this a weapon? Things. And in China, Alibaba is held accountable to all those things. Anyway, tons of examples. Let me briefly take a moment and explain how deep learning works, because everyone asks this question, okay, how does this work? First, there's 2 parts of deep learning. The first part is teaching a computer about something. It's training a neural network. You start with effectively a blank brain or neural network, and then you just pump it with a lot of data. You give it trained data, so it says, here's a picture of a Gucci bag. Here's a picture of a pencil. Here's a picture of whatever, or here's a WAV file of the word cat. You do this a lot. You do this about 100 million times. And the neural network software, the training software, actually processes this, and the brain learns over time. And you monitor the learning. Sometimes it works, sometimes it doesn't. You You have to go back, and a data scientist who's an expert at this will do this many times over until they get to an accuracy level of about 80, 85, or 90%. Once you get to that level of accuracy, you can then turn around, take that neural network, and bring it over to the deployment side. Here we call this inferencing. Data comes into the data center, either a real-time request like a voice search, or you're just mining the data that you already have, your cold storage, to extract some learning. And you do typically about 1 billion floating point operations on each of those pieces of data and get, as a result, a calculation. This is this person said cat. This is a picture of a pen, or whatnot. As you can see, this is an incredibly computationally intensive operation. It's really changing the way people build data centers from being just web hosting or Hadoop or others to being a compute-rich environment, which is why GPUs are being deployed in Azure and many data centers all over the world. The majority of the AI, every deep learning framework, the framework is the software that does the training, that data scientists are using, are all built on top of GPUs. GPUs run these neural networks about 10 times faster than a CPU can. So that's why GPUs are predominant in AI, and you see them everywhere. Just some examples of the neural network software that people have. A lot of it's academic driven. Some of it's also run by companies, including Microsoft's own CNTK software. Let me give you a couple of quick demos. I know it's kind of what can AI do. Video is a hot topic right now. A lot of social media data is switching from being text to images to now video, and people sharing video. Customers want to understand what's inside the video. What is it? What's happening? Is this appropriate video for me to share? Should I share it with Corey or someone else, or not share it at all because it's inappropriate? This is an example of what a single GPU can do. We have here over 90 video streams coming into a GPU in H.264. On every single frame of all 90 of those videos, we're running a neural network called GoogleNet to understand what actually is happening inside of these pictures. And if you can see here, it actually is labeling each of them to say this is a military parade. Here we have a javelin throw. A toy example, but you can imagine you could train this on anything. It's happening on every single frame of all 90 videos in real time to give you a perspective of the kind of performance GPUs can bring inside of Azure. As we keep going, you can then filter that and clean it up and decide which ones you want to use. Here's another fun example. This is a neural net that was trained on paintings of Picasso. It was given every single Picasso painting, and then you feed into it every frame of the video, and out comes what Picasso would have done with that frame. This is a real-time demo running on a single GPU to generate real-time Picasso videos. And we have a bunch of different styles, so let's go through. Kind of gives you a feel for the fun things you could do with neural networks and the amazing things that this technology can deliver. So there's a high-level view of what AI is, and I'll hand it back to Corey, and he can continue on. But thank you.
Thanks, Ian. That's awesome. That's fantastic. So why don't we show you actually a real-life running example of training right here on stage with Brian Sarase, who will lead a demo running this.
Thank you, Corey. Look at this really quick. Hi, everyone. My name is Brian Sarase. I actually work for Corey, and I'm going to highlight, I'm going to be on stage actually a couple times doing a few different demos. And the first thing I want to do is actually kind of emphasize a little bit of what Ian's been talking about with the new GPUs. So what we're going to do is we're actually going to kick off a deep learning training demo that's actually going to program up a handwriting recognition piece of software that we have running. So let's go ahead and take a look. It should be, you did pick the wrong one. That's the right one. Okay. So what we have here is this is an SSH connection, and we're actually connected to two different virtual machines. On the left-hand side, we're actually connected to a D-series virtual machine that has two CPUs. And on the right-hand side, we're actually connected to one of our new Linux GPU virtual machines that's running in our GPU preview cluster. And what I'm going to do is actually kick off the exact same script on both sides of the house. So let's go ahead and start it. I'm going to start on the left-hand side and kick off the script. I'm going to move over to the right-hand side and do the same thing. So what we're doing again is training up a handwriting recognition model. And this model is simply designed to be able to recognize what number someone physically handwrites. And in order to do this, we have to train up the model with 60,000 images. And that's what's happening right now. It's actually processing through 60,000 images to be able to detect handwriting. And if we take a look at the left-hand side, I'm going to go ahead and zoom in, you can see here that our samples per second is going around just a little under 800. And right now, we're on process 1 of 15. Now, if I switch over and take a look at our GPU virtual machine, you can see instead of 800 samples per second, we're doing about 12,000 samples per second. And instead of being stuck on process 1 of 15, we're right now on process 9 of 15. So we're approximately 20 times faster in working our way through those images. And then something else to realize is this is actually running on a single GPU virtual machine. As mentioned, we can actually scale up to 4 GPUs for virtual machine. And then also, we can scale out using InfiniBand to multiple GPU virtual machines. So when you're doing processing of some of the things that Ian showed with lots of images, real data sets can be millions and millions of images big. And so the ability to do this quickly using GPU and multiple GPU virtual machines is going to be key. And so now if we take a look on our right-hand side, we're actually complete. We've worked our way all the way through the 60 images. And for fun, let's go ahead and see our handwriting model in action. So what I have here on the left-hand side is simply wonderfully Microsoft Paint. And I'll ask the audience, I need a 1-digit number between 1 and 9, any number. All right, I heard a 4, I also heard an 8. Let's start with a 4. So I'm going to draw a big old 4. It's the best I can do with handwriting. And I'm going to save, and on the right-hand side, I'm going to kick off a little script that'll actually run our model and do the detection. And if we zoom in, there it is, classification result 4. And for fun, just because I like to play with Microsoft Paint so much, let's do one more number. Give me one more number. 8. That is a hard one. Let's see, I go this way. Oh, shoot. I so want to draw an 8. There we go. Big old, oh, that's an ugly 8. Let's see what happens. I'll go ahead and run it again, and we look down at the bottom, and there's an 8. So again, the emphasis not here is on our model around handwriting recognition. The emphasis is really how quickly that we were able to process through all those images for the training. And actually, if we go back and take a quick look, you can see over here on the left-hand side, we're still on process 3 of 15, so it's still working on the CPU virtual machine. So with that, I'll hand it back over to Corey. Thanks.
Thanks, Brian. And I know what you're all thinking. It's how many times have you needed a solution that can read a number from a paint shop thing? Anyway, no, but what an awesome story, I think, from the overall GPU story and the power that this is going to bring. And I think some of the examples, at least, that Ian talked about and then that Brian showed, it's going to touch every one of the industries that we're working on. Every one of the verticals are going to see this type of deep learning and this visualization requirements really pop up. So it's really exciting. It's been a great partnership to work with NVIDIA on this, and I'm looking forward to seeing what you guys all do with it as this continues to grow. All right, so one of the other aspects of getting this agility, of being able to deploy quickly, now that we're sort of moving beyond just the VM, is our ability to scale very fast and very broad very, very quickly. And this is what the VM scale set is really all about. VM scale sets offer this ability to do auto configuration, auto scale using a pre-configured setup of your infrastructure. So you can come in and say, here is what I would like my virtual machines to look like, and this will automatically deploy and configure it for you. And so it allows very easy updates. You can roll through OS updates this way. You can roll through additional tweaks to your virtual machine. You can add endpoints, load balancing, all of these things incredibly easy to go make these updates and manage them accordingly. And so this is something for that type of massive scale agility that you're looking for, a very, very common solution, and you'll see a little bit of a demo of that later. Then add on top of that what you can then do for if you're not just dealing with virtual machines, but you actually are thinking in terms of jobs. And this is something we see for a lot of customers, folks like Towers Watson or Milliman, who are doing massive scale-out computation, who want to take advantage of some of the sizes we just talked about. But all you want to do is think about it in terms of I want to execute a job versus I care about a virtual machine. And so what this does is it actually will take your job for you, distribute it out across across a set of infrastructure that you assign to it, and it will deploy it for you, which means if the job fails, it will redeploy it somewhere else. If the job needs to finish, it can launch up and auto-scale for you. Windows, Linux automatically takes care of that for you from a job perspective versus from a VM perspective. So again, trying to enable you to focus on what you're trying to get done so that you can get it done quickly and very comfortably and easy. Okay, so with those focus on virtual machines and focus on compute and focus on jobs, I of course need to spend some time talking about containers. So the first big question that I think is worth answering, which maybe all of you know, is sort of why containers? Why have these gotten so popular? Why is everyone talking about them? So I thought I'd spend just a minute on this. And it does come back and pull back quite a bit to the overall theme we're talking about. They're very fast and very agile. They start up nearly instantaneously, and they remove a lot of the management complexities that you've had with VHDs, with VMDKs. You can now move these things around incredibly easily. They're fully contained, and they just simplify both the development and the deployment story with this unified experience. And as sort of Docker will say, build, ship, and run, the entire process becomes incredibly easy with this story. And so if you look at sort of the way this will play out, whether you're deploying onto a dev box or a test box, let's say in the public cloud, and then maybe prod you're bringing back on premises, your containers stay the same, they deploy the same, and they deploy incredibly fast in all of those environments. And so this is the allure of the container story. And of course, with Docker and what they've done, amazing to build this community around this story, to build this unified deployment model, to now have thousands and thousands and thousands of images available in Docker Hub, and of course, the management experiences all around that with Docker Data Center. So we're seeing a lot of excitement around this, and really the way it's going to change a lot of the way we manage applications and infrastructure. So given Windows Server 2016 launched GA this week with container support, I thought I'd spend just a minute explaining sort of how those work inside Windows Server 2016. So the biggest difference here, containers versus virtual machines. Virtual machines are hardware virtualization. So with virtual machines, you start and you virtualize the actual physical hardware. So it's simulating registers, it's simulating CPU, it's simulating memory, and presenting that to the virtual machine running on top as if it were real. And the VM is running, the OS is running, it thinks it's running on actual physical hardware. And that's the gist, but that's why it's so cumbersome, right? You have to carry around the full virtual disk, whether it be for VMware, Hyper-V, etc. You have to carry and manage that, and the whole thing moves with it. It also is why it takes so long for them to start, because you have to boot the entire instance. This is where containers change things. They move up a layer in the stack, and they're actually focused on OS virtualization versus hardware virtualization. So the OS is what's virtualized in containers, which means you're sharing that OS across those containers, but they start up almost instantaneous. There's no boot time because the OS is running already, right? The amount of density that you can get, of course, goes up as well because you're sharing an OS versus each one having its own copy as you virtualize this out. And this is really where that power of containers comes in, that speed, that agility, that density. It all changes the map for how these things work. Now, on Windows, we have two flavors of containers. One, the Windows Server container, which it comes with the maximum speed and density, very, very similar to what Linux has as well. And these sort of go hand in hand, and they end up, again, having that OS virtualization. Now, the one interesting solution that we also have as part of Windows Server is the Hyper-V container. And so this now takes that same model that the container model was intended to solve. So it's still carrying around just the app. There's no OS. The exact same container can deploy in Windows Server containers and Hyper-V containers. But once deployed, it pulls from the underlying OS, just like Windows Server containers, but then it isolates it. So it effectively pulls from the underlying OS at deploy time and then wraps a boundary around it and then virtualizes it as if it were a VM at that point. So your density does go down. The start time does go up a little bit, but you have that same consistent model, so that same amount of agility that you'd expect, but you are perfectly secure from each individual container as if they were virtual machines. So you have the choices here, right? These choices around your deployment time allow you to pick which way you want to go, but because they use the same consistent model, you can choose a deployment time. So the developers don't need to know or care about this. It's effectively what is the environment you're deploying into and what is the level of security you want in that environment. That's your decision point here between these two. And so once you've figured out, great, so now I get containers, but what the heck is managing these containers? What is going to figure out which hardware this is deploying to? Right? It's still going to deploy on hosts. It's still going to deploy on underlying virtual machines. What are those virtual machines? Well, this is where the Azure Container Service can come in handy. The Azure Container Service is effectively a deployment solution and a management solution for open source container orchestration. What it does is you get to choose between DCOS, a product by Mesosphere, or Docker Swarm, a product by Docker, to be able to deploy across a set of infrastructure, a set of virtual machines, scale sets, which I just talked about. And it deploys this orchestrator on top. And what this orchestrator does, it picks where to deploy containers to. So when you're saying, look, I want to deploy these 3 Linux containers for my front end and these 2 for my back end, the orchestrator decides where to go. Right? It's sort of the modern day manager of infrastructure, but now at the container level instead. Of course, today all of our solutions are fully open source, which means you can run the exact same orchestrator in Azure as you can run on other clouds or on-prem, but we simplify deployment and we simplify management, which is really the value we're adding with Container Service. Today's Linux only, so that's another interesting part of this platform. We are adding Windows Server support. Now that Windows Server is GA, you'll see that pop up later on. And so that support is adding across both DCOS and Swarm. So at this point, it is also worth just giving kind of a view of how this sort of plays out, because I think there's a lot of confusion around, I don't quite understand the layering of how this infrastructure all plays out. So you've got this bottom layer, which is dev, servers on your on-prem environment, virtual machines, or cloud, and you may want to deploy your containers on any of these. The orchestrators then are sitting on top, and these orchestrators, all of them have open source components. They can deploy anywhere. Right? So whether it's us, whether it's AWS, whether it's developers, servers, on-prem, these solutions can deploy there and manage those deployments. And so that's how you're choosing effectively how to orchestrate on your infrastructure underneath. And as I've talked about already, these middle 2 are the Azure Container Service that's supported specifically there. And so you can use the Azure Container Service to deploy out onto those environments. Your packaging then is what type of container? Are you Linux? Are you Windows? Are you Hyper-V? And so that's where you're deciding what type of container, what type of deployment option you want. And then, of course, the top layer is the app itself. Right? And so you can imagine this flow. The developer builds the app, puts it into a container. The container then, based on deployment options, which type of container do you want it to be? Your orchestrator that you've already chosen, and then, of course, sitting on top of a set of hosting options that you would want to deploy underneath the virtual machine layer at the bottom, or the hardware layer directly onto physical hardware as well. And so this is intended to give you this whole thing is still container infrastructure. This whole thing is still how containers deploy end to end. And that is intended to give sort of a nice, clear picture of sort of how this layering works. Okay. And as we look at the future of Azure, so I've talked about the Azure Container Service, and of course it's geared towards the ability to deploy containers in the Azure Container Service itself. We are looking at adding container support everywhere. So all of our services, because in the end it is just a packaging format. So you'll see us talk about containers as part of all of our development, all of our compute services. This is going to be a big push for us, and we think it's a really big important area for the entire community to drive, in that this does push the agility that I've been talking about. The ability to deploy these containers dramatically improves that. And then, of course, CI/CD on top, getting your continuous integration, your continuous deployment to be able to manage that, and whether that be our solutions like Scott showed with VSCS or Jenkins-based solutions as well. Okay, and with that, why don't I actually bring Brian back up to be able to show us a little bit of what VM scale sets and the container service look like.
Thank you again. Hello, everyone, again. So we want to show a couple things. As you mentioned, scale sets to start and then containers. The Azure portal team has been doing a lot of work to make it easy to both deploy VM scale sets and manage VM scale sets directly through the portal. So I want to take a minute and just show how easy it really is. So let's take a look here. Here is the portal, and I am simply going to click on New. And at the top, I'm just going to type in the word scale. Now this will bring up a few different hits, But the first hit that we have here is Virtual Machine Scale Set, published by Microsoft. So this is our template that will automatically deploy a scale set into Azure. So I'm going to go ahead and click and say Create. Now, the first screen that comes up is our basic settings, so I'll go through this pretty quickly. Our virtual machine, or our scale set name, I'll just call it Scale. We'll go ahead and choose Linux as the operating system. I'll type in my username. I'll carefully try to type my super long password twice. Did I do it? Yay. Okay, and I'll go ahead and put this in a resource group. I'll just call it RG1, and deploying to North Central is just fine. So here's the second setting page. And this is the interesting one because it gives you all your configuration options specific to the scale set. Takes just a second for it to pop up. The first thing it's going to ask is around the domain, so I'll go ahead and enter that quickly as soon as we have it. Here it comes. There's the domain, and for simplicity, I'll just type domain. Now we go ahead. We already told it that we want it to be Linux, so now it's giving us an option for a disk image. I'm just going to go ahead and pick OpenSUSE. Our instance count, let's go ahead and make this a 50 virtual machine scale set. And then down here, you can see it automatically updates itself in its 50 standard D1 V2s. I'm going to go ahead and just choose the D2 standard right there. And then down here is our auto scale options. Assuming you want to do auto scale with your scale set, all the configuration settings are right here. What is the minimum number of VMs you want is 1. We'll go ahead and set this at 50. And then here we have our scale out and our scale in settings. If the CPU threshold hits 75%, it's going to go ahead and deploy more virtual machines. The default here is 1. This is going to be a mission critical workload, so I'll go ahead and have it deploy in sets of 2. And then if the threshold hovers down around 25%, we'll start pulling those virtual machines back at a rate of 1 at a time. So right here, you can see how quickly and easily you can set up a brand new scale set directly through the portal. And also, if you already have a scale set deployed, management through the portal has become a lot easier as well. So now I'm going to go ahead and open up a scale set that we've already deployed. And let's take a look at some of the settings that we have. Here you can see it's also running Linux. It's running the standard DS1 virtual machine size, and this is a 100 instance scale set. And if I go down into the instances themselves, it'll take just a second, but you'll see all 100 virtual machines show up and their current state of activity as well. There they are. So here's our 100 virtual machines. They're all running, and they're all adhering to our latest scale set model. But what's great here is right in the UI, I can go ahead and select several of these virtual machines, so I'll just go ahead and grab some. And at the top, we can take action against all the virtual machines that we set. For example, I can restart these virtual machines. I can deallocate them and take them out of our set. I can also, if we think that they're munged up or they're doing something weird, I can go ahead and re-image them and set them back to their base state. I can also delete the virtual machines, and if I wanted to, I can select all the virtual machines and upgrade them as one large batch. So here, management of the VM scale sets is very easy. And of course, this is all on top of our APIs. And you can also use those APIs to integrate with your own management interfaces or make your own tools. And that's actually what I have up in this screen here. This is a simple tool that we've created that is also managing this exact same scale set. Here you can say you can see that we have our 100 virtual machines, the operating system that they're running. Here you can see the version number. It's running 899.15. And what I'm going to go ahead and do is change this model number to 17. And I'm going to go ahead and update model. And then at the bottom, we have batch size. So in here, you can see all our virtual machines. Across the top, you can see our various fault domains. And across the left-hand side, you can see our various update domains. Now, if I wanted to go ahead, and since I updated the model, any new virtual machine that's deployed will take that new model. But if I want to push that new model to all the existing virtual machines, we can do what I just did, which is right now, I'm doing a rolling update or a rolling upgrade of all these virtual machines, and I'm doing them in a batch size of 18. So 18 virtual machines at a time are going to go ahead and roll to the next version. And when those are done, it's going to move on to the next batch as well. So here in summary for scale sets, you see how easy it is to deploy scale sets in the UI, manage them in the UI, and then also use the APIs for your own set of tools to do advanced management as well. So the next thing I want to show, before I hand it back over to Corey, is containers. So here we have DCOS. This is the dashboard view. This view is showing us our entire container environment or our clustered environment. So here you can get some general information. You can see our CPU allocation is running around 71%. Our memory allocation is around 21%. You can see if we have any failures. You can see the tasks that are currently underway. Down here you can also see that we're connected to 7 nodes. So this is actually 7 virtual machines that are hosting all of our containers. And then if I move over to the second screen, this is Marathon, also part of DCOS, and this is actually showing us a container by container view. So looking at what we have on the screen here, in the middle, we have our 6 containers that we're currently running. And over on the left-hand side, we just created a little chart that's going to be tracking both the queue length and the processing time. So what is this application that we set up? This is actually just a simple e-commerce application that we set up that is designed to process people's purchases as they come through the website. So when we look at our different containers, the first one I want to highlight here is our analyzer. Our analyzer is just that. It is the one that actually processes the requests and completes the orders. The second one is autoscale. This is what's paying attention to how many orders are coming in and whether or not we need to scale up the analyzer service. And the third one is batch. Now what batch is doing is it's actually a secondary application. It's a non-mission critical application. In this case, it's just doing data mining of all the data that we're receiving through our purchase orders. And what we want to do is we want to use batch on those resources when they're not being used. So we want to use all of the container resources and all our cluster resources to run batch. But if we have a big push of new users coming in and orders pushing through, we want to reduce down batch and we want to bring up our critical mission workload. And then the last one here that I'm going to talk about is the producer. The producer is essentially our load generator. This is what's going to simulate multiple users coming to the website and making orders at the same time. So I'm going to go ahead, and we're going to go ahead and up the producer. So I'm going to scale the producer to 2. And actually, before I do that, I want to highlight one more thing. Right now, the batch is running about 4 containers or 4 processes going on. And if we look back at our processor speed, we're hovering about 70 to 80%. So right now, that secondary job is taking up about 80% of the CPU. So when we go back and we actually scale up our producer and start generating load, simulating active users making purchases, you're going to see a couple things happen. Over here on the left-hand side, you're going to see our queue length go up significantly. So what's happening is, again, we're starting to generate thousands of users coming across the system and generating load, and 2 things are going to happen. Number 1, the autoscaler is going to start to reduce batch and run less on batch because it sees a mission-critical workload coming in, and it's going to start adding more analyzer containers to the system. So right here, you can see our queue length has already jumped up to 56, 57. You can see that our batch is down to 1 instead of 3. And on the analyzer side, it's starting to deploy more and more to be able to take up that workload and process those orders coming in. And you can see, as Corey mentioned, the thing here with containers is how quick it happened. We all of a sudden simulated thousands of users hitting this simultaneously. We brought down batch, we brought up the analyzer, and in a matter of just a couple seconds, you see that spike that went all the way up, it's gone all the way down. Because we have over now 30 containers running to process all that workload. So the key thing here is using containers, you can act very quickly and very rapidly to take advantage or to fix what's happening in the real world. And also all of these resources that you're putting into this service, you can use, for example, as we did, for batch to run processes when the system is idle. And then those processes can go away and you can bring up your mission critical processes when you want as well. So it's a great return on investment to make sure that you're utilizing that hardware. So with that, I'll turn it back to Corey again. Thank you.
We'll get it at the end. Yeah, we'll come back with questions at the end. Yeah, thanks. Great, thanks, Brian. That's awesome. And the key thing just to call out is, of course, everything that Brian just showed you is fully open source solutions. And it's really been a big theme for us in the platform to offer the development choice that you have, the management choice that you have, something that I think has been a really exciting part of the Azure story. And so this choice and flexibility across a wide variety, whether it be management support and application support, whether it be frameworks and programming languages, databases and middleware, and of course operating systems, of which I've already talked about. This choice and flexibility is a prime mandate and expectation of our platform. It's something we've really focused a lot on, a lot of great partnerships throughout the last few years to build this. A couple of specific examples here, PaaS on IaaS, the support for Cloud Foundry, OpenShift, even Kubernetes, Elastic, and Apprenda, offering this variety of PaaS solutions to run straight on our IaaS story. And in fact, Cloud Foundry, great partnership with Pivotal. And in the next month, we are actually planning to release the full support for Pivotal Cloud Foundry with Operations Manager on top of Azure. And so that's a great new enhancement, great new support that we're launching with the Pivotal team to be able to deploy, again, this PaaS-based solution on top of IaaS, a very open source focused and very sort of broad reach focus. Also on the data side, a lot of data solutions all running on virtual machines. Of course, also a set running as part of our data platform to be able to take these open source solutions and launch them, whether it be Horton, whether it be Hadoop, whether it be Cassandra as part of DataStax. These offerings are very, very broad and very capable to run these open source solutions on the platform. And in fact, we have a very special guest here with us, a gentleman named Subrotu Chakrabarti, who is the Director of Digital Experiences and Loyalty at Albertsons, and he is going to tell us a little bit about how they are using open source technologies and solutions on Azure today. So, welcome. Thanks.
Corey?
Yeah, welcome.
What we are going to talk about today is Albertsons Company's journey to the cloud. We are pretty much at the beginning of the journey, I would say, but it's a huge change for a company like Albertsons Company, which is that IT is fairly traditional and very risk averse. So this is a huge step. We have actually come a long way. So I just wanted to share with you, where we are at and what we're doing. Is it a click? Okay. So the reasons why we are moving to the cloud, right? The burning reasons are, first thing is agility. So what does agility mean? It's all about easy experimentation. And when I have to experiment with something, when I have to try out something new, I don't have to spend boatload of money or go for a longer term contract with anyone. It's about trying out, it's about experimenting things. That's what was one of the biggest driving factors. The other one is access to innovation. So like as Corey showed you in the previous slides, there's like a whole bunch of things that are offered on the cloud as a service, and you can just tap into those services, again, without going into a longer term contract. And these are things that really appeal to us because we just did like a machine learning POC. We just spun up a whole bunch of resources, ran Revolution Analytics on it, and we just turned the whole thing down. And that's how it goes. The other one is decreasing cost. Now, cost is a more relative thing for companies like us that have spent significantly in setting up our data center. But the way I look at it is a lower incremental cost when you want to try out something new. So the whole thing kind of ties together that when you have a burning need to experiment and you're trying to innovate on something and you don't want to burn your bank for that, cloud is a great fit for that. So the first candidate for us was the loyalty application. This is our consumer-facing application that is essentially, today it is more of a couponing application, and I'll go into the details of that. So if you look at the loyalty application, there is no fixed set of requirements for the loyalty application. It's all about understanding your customer's needs and providing value to the customer where they need it, when they need it, and how they need it. So this was the application that we selected for the cloud because we need to constantly experiment out new things and innovate and do that at a reasonable cost. So just looking at what the loyalty application does today, it basically displays a whole bunch of coupons. Now this set of coupons is not like sending you the flyer at home that you just pick up from your mail and just throw it into the recycle bin. That's not what this is about. This is not blasting coupons all over the place. This is personalized coupons. So it's based on your purchase habits. So the customers get to see what their relevant content. It also has certain other features, like you can build your shopping list. And when you build your shopping list, you go to the store, you can sort and categorize your items in different ways. And one of the features that our customers really love is the sort by aisle list. When you create a list of items, you can sort it by aisle so that you know exactly where your items are, which has discounts associated with it, and so that you don't have to go across the whole store or go back and forth in the store because you made a list in a different order. So now looking at the application. So this is the application that we migrated to the cloud. How does it look like? So cloud enabled us to pick solutions from different types of solutions, some PaaS, some infrastructure as a service, and bring all of that together. We are traditionally more of a Java-based skill set is what exists in our company. So we selected tools that we could actually fit into like some infrastructure as a service, some platform as a service. So the stack this is how the stack looks like after we migrated. We actually did not just lift and shift migrate. We rewrote the application to go into something that is more linearly scalable and also lightweight. So this is how it looks like. We have like Akamai as our CDN we use, and this is outside of Azure. Then we use Azure APIM, which is pure PaaS. Then we go into Redis for our caching, which is also PaaS from Azure. We run Play Java for our application servers. And this is, today it is infrastructure as a service, but we are very quickly migrating to platform as a service. And when I show you the next slide, it'll become evident why we are doing so. And then Azure Service Bus. This is another pure platform as a service. Then DataStax Cassandra. This one, we have to run it as an infrastructure as a service, because at the end of the day, we want to get out of this mold of doing server maintenance. We want to focus on more of the business logic and building new features. And then we use Spark and HD Insight for our analytics. So this is like a very high-level network topology, and obviously I don't think you can read this slide. But just to point out, what we have done is we have actually broken down our application into multiple microservices. And because we are running these microservices on infrastructure as a service, we are basically spinning up multiple VMs. So if you have that many VMs, it's a lot of maintenance at the end of the day. That's what we realized. So that's one of the big reasons why we are migrating to pure platform as a service, which is app service. And then we have, if you see on the lower side, we have the DataStax cluster and the HD Insight cluster. Rest of the diagram is more about the management VMs that we run. You still have to run some VMs there for administration and management, but essentially that's what it is. With that, I'll turn it back over to Corey.
Great. Thanks.
All right.
Thanks, Alberto. It's just awesome to see the ability to take all of those different services and bring them together into a single picture. Some of them being open source solutions running on top of VMs, and some of them being, as he talked about, some of the higher level services, which will actually be the focus for the rest of the talk. Some of the platform services sitting on top, solutions like cloud services, Service Fabric. You heard mention quite a bit about App Service, and of course Azure Functions. And so this gets us to the top. So to start off, he also talked about microservices and how they built their platform using a microservices architecture. It's great to see that, and it is something that we're seeing a lot of uptick on. So let me spend just a minute on sort of outlining what this is and why this is so interesting. So when you look at a lot of the classic applications, three-tier applications that exist today, front ends, middle tier, back end, your data tier sitting there, the biggest problem that exists today is these are fairly monolithic, large chunks of code, application, integration. Makes it very hard to make updates without extensive testing. Multiple teams need to be involved. Everyone needs to sign off on things before you can deploy updates to any one of the tiers. This is, of course, very contrary to the point I mentioned at the beginning, where agility is one of the most important aspects to consider when you're moving this transformation into the next generation. And so the idea behind microservices, take these large chunks, this web chunk, this business logic chunk, and split it up into more independent components. So web being split up into an HTTP listener, page content, maybe an authentication section, and each of them can be updated independently. So they're individually built, they're individually deployed, and they're small and independent services, each with their own life cycle and their own contracts between each other. And so that's an important point and why this takes a lot of work. You actually have to go write new contracts between each one of these microservices so that they can be updated independently without having any impact on each other. Otherwise, you still have that spaghetti integration that exists today with those monolithic services. So it does take a lot of work to go rethink in microservices. But once you're there, it's so much easier to manage, and you can update in so much more agile way. And so it is a really, really valuable part of the overall service. And this fine-grained, very loosely coupled support is a big aspect of what makes microservices so agile and so powerful. And so when you look at sort of microservices with Azure, certainly these are likely built on some set of virtual machines, some virtual machine scale set. And sort of the two options we've talked about already today, one being container service, where you can build and deploy this microservice style architecture just using a set of containers. You can even do it with a set of virtual machines, frankly, right? It is simply an architecture model. Containers are much more conducive to this small independent component, but it's not necessarily required. Service Fabric, as an offering here in the middle, very unique in that it offers a fully prescriptive environment to be able to deploy microservices. And so this is something we've been running internally for many, many years. It runs services like Skype for business. It runs services like SQLDB. And the capabilities offered as part of Service Fabric include this model that makes microservice management incredibly easy. You can do both stateful and stateless microservices using Docker containers. You can run .NET, Java APIs, Windows and Linux support. And here's the real great thing. You can run this in a standalone way. So you can run this, of course, in Azure and using Azure virtual machines, but you can even run it in a standalone deployment that can run on premises. It can run in other clouds. And so this allows you to take this application model and take it anywhere you want using Windows or Linux. So very, very powerful, very, very capable, and again, sort of an easy way to get going with microservices as part of your application model. Not the only way, but a very, very easy way to be able to deploy to that. And then going to effectively to the very top of the stack here and being able to deploy web, mobile, and event-based services using the Compute platform as well. And so to start, Azure App Service, actually our most popular service in Azure, offers the deployment across a set of different application models. The primary two here, web apps and mobile apps. it's incredibly easy to deploy a web app using Azure App Service. You hook it up to GitHub, you launch it, you can run just a node solution, and you've got an app running within a couple minutes. Very, very fast, very easy. It will then integrate with your GitHub environment, and there's no server management underneath. Similar story with mobile apps. With mobile apps, you have integrated push capability, very fast to get going, and of course, sitting without any server management. So you have no updates underneath, you have no management of the server that you're sitting on, and that dramatically simplifies, of course, the overall management requirements you have. And then add on top of this Azure Functions. So Azure Functions is a very unique offering and sort of a very innovative next generation solution to be able to do event-focused computation. So what this does is, similar to websites and mobile, you end up deploying without any server management underneath. But even more interestingly, with Azure Functions, it's completely event-driven. So an event happens. Let's say you drop an image into a storage account. What this will do is it will fire an event and run some code, right? And so when you think about the capability there, the other important aspect, you only pay for when that code is running. Right? And so it really comes down to the cost structure that you'd expect from the most agile cloud cost structure you can get. You pay per execution. It triggers on events in Azure or even external services. So you can trigger it on a common in GitHub, and you can make it then fire a function to be able to respond. And again, you're constantly just paying per use. And so it brings together this code, this very simple code to write, C# and Node built into the platform. You can also run any executable you want as part of this. And it brings that together with the events and the data inputs and enables you to quickly launch and quickly run. And so this capability, very, very powerful and enables a really, really fast deployment without having to pay a lot to get these services up and running. And so, you know, I've mentioned a couple times the lack of server requirements. On both of these services, a very, very key point is they have no server management. They have no server patching, and you do not need to think about scaling in terms of the server. This is really, really nice. Right? It removes a lot of the complexities around management and pushes them up the stack. Now, with Azure Functions, there's even an additional point here, right? And this is an important point. It's also the transactions are built in a very granular way. So with web apps, you spin up a web app, and you're still billed for the running of that web app. Now, it's not a full server. It's a subset of a server, but you're still building for the ongoing running of that web app. With Azure Functions, you are billed for just the transaction. You are billed for just the execution of the function, which makes it even more serverless in that regard as it approaches the billing model. And so across these two, you've got the serverless support on app service. You've got the great serverless support with functions, including that transactional billing, enabling a much easier, much faster, and much lower management set of requirements to deploy your applications. And so as you look at this top portion of the stack, obviously the agility gets better and better. The ability to deploy quickly, the ability to update fast, and the ability to scale out very fast, very, very powerful as you get to these top level services. And so it does bring me back to this microservices slide. And we have started seeing some interesting patterns where people are using Azure Functions to build microservice-based applications. So as I mentioned before, microservice-based applications are an architecture construct, right? They're a way to build an application. It has small little granular pieces, and they end up being independent and updated independently. With Azure Functions, you can start putting this together and have those functions, in some situations, be those microservice-based solutions. And so you can start maybe layering these things together. You can start having full application solutions with one or the other. And you can effectively build microservice-based applications using any of these components. Right? And so we are starting to see this. It is pretty challenging, to be candid, to build sort of a full application model thinking purely event-based. The brain doesn't actually work that way sometimes, and so it does take some work to think that through. But oftentimes a combination of these can be very, very powerful, and we see a lot of that in actual deployments and in actual applications. And this is something that I do think we'll see more and more of this again as that agility demand really picks up. And so to kind of give you that combination of these three things that we've talked about here today, and try and give you a little bit of a sense of sort of the differences here, because these are frequently confused and overlapped. And so I think it's valuable to spend just a few minutes on this. Containers really are application packaging, somewhat similar to an XC or a jar. I'm not sure necessarily the Docker folks would agree with me, but in a lot of ways they really are just carrying the code in a much more innovative way than has been done before. And agnostic to the underlying platform, but they are still effectively a code carrier. Then serverless is actually a trait of the platform. So serverless is not a trait of your app. It's not a trait of the container of the app. It's a trait of the platform. So it will dictate the work you have to do and how you pay your bill, right? And so serverless for us, app service, serverless for Azure Functions, it dictates your management construct and it dictates your bill, right? But it doesn't say, well, your app has to be serverless in this way. Well, no, you can have an app be written for serverless platforms or not, and they can probably move. And it really just changes the way in which you engage the underlying hosting environment. And then the third is microservices, and this actually is an application construct, but not necessarily a platform requirement, right? So the application itself is thought through as a microservice-based application. That's the design, that's the architecture. It's like a 3-tier app or a SOA app or a PubSub app. Microservices is just one in that list. And there are platforms that are great at managing microservice-based solutions. Service Fabric happens to be one, in my opinion. But the idea here is that this is not a platform, but more a capability, a architecture construct that then can be applied to different platforms. And so they are all very different. Now, they overlap a lot, right? So we will see most microservice-based applications use containers. I think that's my expectation, as containers help isolate the code. So it ends up being kind of an obvious combination, an obvious marriage, but that's not required. There are a lot of containers that are not microservice-based solutions, and a lot of microservice-based solutions that don't use containers. But you will see a lot of these pieces come together, and my goal was to try and demystify this a little bit, because these terms end up getting pulled together a lot. Okay, and so with that, with the capabilities in this top portion of the stack, a lot of the infrastructure support you saw earlier on, the ability to deploy brand new innovative hardware at the turn of a crank, or I guess a few clicks of a button on your laptop, and being able to scale out very quickly, whether they be containers or whether they be VMs. It's all about delivering on this promise of agility. Being able to take this Azure Compute stack, being able to transform your businesses, transform the next direction of where you need to go, where you need to take your customers, where you need to take your internal employees, and how you're going to bring them into this new digital age. As part of that agility the Compute platform offers is there to help you. And we think that application transformation will be led with the agility of these Compute platforms. And as we look into the future, it's all about more of everything I just talked about. So more regions, giving you closer proximity to your customers, more sizes. You're going to see continued advancements, continued innovation on our solutions that we offer with sizes, continued enhancements on our GPUs to be able to grow and expand the possibility of what our sizes can do. You're going to see more services, more platform offerings, more capabilities to deploy quickly and with great agility. And more development solutions, end-to-end solutions to be able to develop, manage, continuous integrate, continuous deploy on the platform. And of course, more management controls. I didn't spend a lot of time today on this, but the ability to control using things like Azure Monitor and Operations Management Suite, of course, needs to be there, or that agility quickly can go down the drain as wasted effort because you can't manage things. And of course, all these come together to offer much more agility. And so with that, I thank you guys very much for your time. I hope you enjoyed the session. Please make sure you do fill out a form and give feedback, and enjoy the rest of your Ignite. We will stay up here for questions afterwards, but I want to let the rest of you guys go. So thank you so much.